We're going to talk about section 1.6, which is rankings. So this is what you do when you're voting, and the order of the finishing matters. We need to know the place of each candidate and not just the first place winner. So we're going to go back to the math club election, this same election that we've been talking about for several lectures. And instead of just electing a president, we want to elect an entire board, a president, a vice president, secretary, and a treasurer. So we're just going to do it by giving first place president, second place vice president, third place secretary, fourth place treasurer. So each of our four methods has a very natural extension that can allow us to rank the candidates. They're called extended ranking methods. So extended plurality, the candidate with the most first place votes wins, and then the next most first place votes get second, and so on. Works the same with extended board account. The candidate with the most points is first, and the second most points is second, and the third most points is third. Okay. When you extend plurality with elimination, you rank the candidates in reverse order of elimination. So whoever got eliminated first is going to come in last. The next person to get eliminated would come in second to last, and just work your way forward till you have a winner. And then with extended pairwise comparisons, in that case, it's also points, and most points win, second most points get second, etc. Okay, what was your question?
What about ties?
Generally, there are a variety of tie-breaking techniques, and whatever organization you're a part of will have adopted it, what to do in the case of a tie in their bylaws or constitution or whatever. But there is no like way to do it. There's lots of different ways.
So, there homework for this. There could be
Right, and if there's a homework problem that involves ties, it will give you instructions on how to break the tie. Yeah. Okay, so here's the math club election again, and we want to determine the winner using extended plurality, extended board account, extended with plurality with elimination, and extended pairwise comparisons. So not just the winner, but the ranking. Who came in first, second, third, and fourth, using each of the methods. So I'm going to have you work through it in your groups. So for the plurality method, we just count first place votes, right? So A has 14, B has 4, C has 11, and D has 8. So my ranking is going to be A, C, D, B. A, C, D, B. So let me put that in a little chart here. Extended plurality A, C, D, B. Okay, let's do Borda. So we have to do points for Borda, where you assign 4 points for a first place vote, 3 for second, 2 for third, and 1 for fourth. So A is going to have 4 times 14 plus 10. Let me be consistent here. Plus 1 times 10 plus 1 times 8 plus 1 times 4 plus 1 times 1. What does that add up to? 79. Thank you. And then B is going to be 3 times 14 plus 3 times 10 plus 2 times 8 plus 4 times 4 plus 2 times 1, and that came out to 106. And then C, I won't go through the whole thing. What's it come out to? 104. And D comes out to 81. So my ranking here is going to be B, C, D, A. B, C, D, A. Throw that in my chart. That's interesting. C and D came in both came in second and third, but then A and B swapped for first and last. Okay, so let's look at plurality with elimination. So I think that this is the one that probably is the most confusing in terms of extended ranking methods. So you start by just counting first place votes. We have 14, 4, 11, and 8. Does anybody have a majority? No, why? How many votes would you need for a majority? 19, good. Okay, so you need 19 votes for majority. Nobody has one, so I eliminate the candidate with the fewest votes, which is B. B is going to be gone. Yeah, D is going to get the votes that used to go to B, right? You just go to the next person in the ballot. So D is going to get those 4 votes, 12. But B was eliminated, right? B was eliminated, so that means B is in last place. B gets last place because they got eliminated first. Okay, still no one has a majority. So who do I eliminate next? C. And who is going to get C's votes? Right, so if I go to these 10, they would have gone to B, but B's eliminated. So we have to skip B and go down to D. And this person's going to get 1 also. So D gets 11 more, which is 23. And that's a majority, so D wins. Right, so C was the next to be eliminated. D is the winner, which leaves A in second place. D, A, C, B. And then for pairwise comparisons, we have to do a head-to-head matchup for all the possible matchups. Okay, so A versus B, A versus C, A versus D, B versus C, B versus D, and C versus D. Okay, so when you match A against B, A is going to get these 14, and B is going to get all the rest. 10, 8 is 18, 22, 23. So B wins that matchup. Okay. Who wins A versus C? A versus D? B versus C? B versus D? And C versus D? Good. All right, so that means that A has a total of 0 matchup wins. B has 1, 2. C has 3. And D has 1. So my ranking is going to be C, B, D, A. C, B, D, A. Just based on who got the most, who got the least points. So some varied results, right? A lot of diversity there. Okay, so we're now going to discuss a somewhat more involved strategy for ranking candidates. So that one was really sort of intuitive. It just was an extension of what we already knew how to do. This one is called a recursive ranking method. It's like a feedback loop. So the output of each step determines what you do next. So in elections, the process is to find a winner of the election, and that person comes in first. So you just carry out the election as though you just wanted to find the winner. And then the person who comes in, who wins, gets first. Then you remove that person's name from the election and hold a whole nother election with the 3 losers, right? So you determine the winner of the losers, and that person gets second place. Then you take that person's name out, and you hold another election to determine who gets third place, etc. You can do this with any of the methods. Yeah.
But when you have the answers?
Yeah. Yeah. Why? It's just another way to do it. So for example, I'll do plurality recursive with you, and then I'll have you try plurality Borda, okay? Right, right. So for plurality recursive, first we just determine the winner, right? So A has 14, B has 4, C has 11, and D has 8. And so we would say A is the winner, right? So A gets first place. Then we have to just get rid of A. We're going to hold a whole nother election where B, C, and D are the only candidates. So it can be helpful to just redraw the preference schedule.
Now, I have a question.
Yes.
When you take out A, for instance, are you distributing A14 to B?
Nope, we're just going to pretend A never existed. So these 14 votes would have voted B, C, D. If they only had B, C, and D to choose from, their ballot would have looked like that.
Wait, so this is
Plurality with elimination. It is similar in that we are going to eliminate someone, but we're eliminating the best candidate instead of the worst candidate. We're going to eliminate the best candidate because they won, right? We don't even need them anymore. They are clearly the winner. Eliminate them. Determine who would win if A had never run. Yes.
so A on that one, so A never existed. You said the function would not be, even though B.
Right, yeah. Yes, you're right. You're right. B would, yeah. So my new preference schedule for round 2, right, would look like this. Number of voters. Would have first, second, and third, because there's only 3 candidates now, B, C, and D. So these 14 people would have voted B, C, D. These 10 would have voted C, B, D, yep. And 8 would have gone D, C, B, and B, D, C, and C, D, B. So then I determine who wins, who would win here. This is like the election for second place. Who would win? So A's gone. B has 18 votes. C has 11, and D has 8. So the election for second place, B wins. So B gets second place. Okay, so now we eliminate B. So there'll only be 2 candidates left, C and D. We want to make a preference schedule where we eliminate candidate B. Round 3. So I'm going to have first and second only. So I have C, D, C, D, DC, DC, C, D. And I could have just had 2 columns, but it doesn't matter. So this is 14, 10, 8, 4, and 1. So C has 14 plus 10 is 24, plus 1 is 25 first place votes, and D has 8. So this is the election for third place. So C gets third place, which means that D comes in fourth. D is the last person left. Yep. All the way to the top?
Yeah, that's
Yes. This is a new method of ranking. It's the plurality method because we're just counting who has the most first place votes. But we're using this kick out the winner to determine second place, then kick out that winner to determine third place. So it's a new method of ranking, but the method is plurality. Yeah. Yes, sorry, I added it wrong. And yeah, see, yeah, thanks. Any other questions? Okay, so I want, what was my ranking? It was A, B, C, D. I would like you to do the recursive, sorry, these are typos. I want you to do recursive Borda, recursive plurality with elimination, and recursive pairwise comparisons. Put your results in this table. Okay, let's discuss some of these together. So for Borda, we already carried out Borda once, right? A, B, C, D. A had 79, B had 106, 104, and 81. Okay, so that means that B wins, right? So B is going to get first place. B gets first. Okay, so now I have to eliminate B and do Borda all over again with only candidates A, C, and D. Okay, so this is going to be A, C, D, and C, D, A, and D, C, A, B, D, C. Oops, no, B is gone. So this is going to be D, C, A, and this would be C, D, A. So everything is, so I made a new preference schedule that only has 3 candidates in it, ranked 1, 2, 3. So I have to do Borda again, okay, with this new preference schedule. So A would get 3 times 14. Okay. But I'm just wanted to point out 3 times 14 because there's only 3 candidates now. So first place gets 3 points, second gets 2, and last gets 1. Okay, and then 1 times 10 plus 1 times 8 plus 1 times 4 plus 1 times 1. And you said that came out to what? 65. Good. And B gets, somebody have the total? 85. And C gets, yeah, D, sorry. There was no B. There was no B. Okay. C got 85 and D got 72. Okay. So that means that C wins the election for second place. So C gets second. Now I eliminate C and have like a runoff for not last place. So A and D. So at this point, my preference schedule is looking a little messy. Maybe I'll just make a new one. So it's going to go AD. Once C is gone, I'm going to have AD 14, and all the rest are going to go DA, right? So how many voters are there altogether? So that's 18, 22, 23, yep. So if I do BORDA on this remaining bit here, A is going to get 2 times 14 plus 1 times 23, and D is going to get 1 times 14 plus 2 times 23. 28 plus 23 is 51 and 60. Yep. So D gets third, and A will get last. So my results are B, C, D, A. B, C, D, A. Everybody come up with B, C, D, A? All right, very good. All right. So for plurality with elimination, that is the one that caused the most confusion.
Can you do that one?
Yep. So first, I'm just going to carry out plurality with elimination to determine the winner, right? So I start with plurality. I say A has 14, B has 4, C has 11, and D has 8. No one has a majority because it takes 19 for a majority, so I'm going to eliminate B. Eliminate B and give B's votes to D. Okay. No one has a majority, so I eliminate C. C's votes are going to go to D, so eliminate C. Plus 11 is 23, so D gets first. Okay, so D gets first place because D wins using plurality with elimination. So I just do the whole method, right? Eliminating the fewest votes until someone has a majority. Once someone has a majority, they're the winner. Now eliminate the winner. So I make a new preference schedule where D is gone because D already got a prize, right? So we're going to have A, B, C, C, B, A, C, B, A, B, C, A, and C, B, A. So this is my new preference schedule. I have to do plurality with elimination again. So I start by counting first place votes. A has 14. C has 19. Yep. And B has 4.
So C is going to win.
So C has a majority. C wins. I don't have to do anything. So C gets second place. Then I have to make a new preference schedule with only A and B. New preference schedule with only A and B because D and C already got their prizes. They get sit out the next round. Carry out the method again with just A and B. So it's just going to be first and second. And I've got AB, BA, 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 BA. So I have 14 ABs. And everybody else is BA, which I think is 23. So A has 14, B has 23, so B gets third. A gets fourth. So it was DCBA. Anybody have results for pairwise comparisons? DCBA? Oh, CBDA? Is that, do you have? Great, good. CBDA. Okay. So the results are different in 3 out of 4 cases. Pairwise comparison, they came out the same. Yeah. Board is the same. Yeah. Things with plurality come out different. Yeah. Which method do you like better, extended or recursive? Extended, yeah. So recursive is one of these things that would be awesome to have a computer do, right? So you wouldn't have to do it. And it's not a difficult program, right? You could write this program. You could do it in Excel. So if there are any computery techie people, this would make an awesome project, right? Because you have to do a project this semester. So writing a program to carry out some of these methods in whatever your favorite format is, whatever favorite program, could be a really cool project.
Really low. Could I just get preference schedules from that big book somewhere and just do an example of everything?
Yes, it would. Really? Yep. It's listed in the project packet. You can read about that option. Yeah.
Can I make a song explaining this?
Okay, so to bring the chapter to a close, summary and conclusions. We studied 4 fairness criteria. Oh, how do they compare? They were mostly Borda and Pairwise Comparisons came out the same. The other 2 came out different. And we liked extended better because it was easier. That's okay. And then I suggested that using Excel or another computer programming language, it could be a cool project. Okay, so conclusions. So we have 4 fairness criteria. There are lots more, but these are sort of the 4 most basic measures of fairness. And any fair voting method should clearly satisfy these 4 things. Majority. A majority candidate should win. A majority candidate should always win. Exactly. Should always win. We have seen that it's possible in certain methods to have a majority candidate who does not win. Okay. Condorcet says that a Condorcet candidate should always win. Right. Majority equals Condorcet. Does not equal. Majority implies Condorcet, but you can be Condorcet without a majority. Go ahead. What's your question? Yes. A Condorcet candidate is a candidate that wins all of their head-to-head matchups. Winner of all their head-to-head matchups. So if you can beat any other candidate in a head-to-head matchup, you should be the winner. But we've seen methods where that doesn't happen. Always. Doesn't always happen. So the monotonicity criterion, that's the revote or the recount one, where if there's a vote and then the only changes between that vote and a revote are positive for the winner, then the candidate should remain the winner. So it was if A wins a vote, and in a revote, there are only positive changes for A, A should still win. So that was the one where that was the example about the International Olympic Committee. They did a straw poll and Calgary won, and then some people were like, okay, we'll all vote for Calgary because Calgary is going to win and I want to have voted for the winner. But then when people changed their vote to increase Calgary's chances, Calgary ended up losing. So that should not happen in a fair system where you can have only positive things happen and then you lose. And then independent of irrelevant alternatives, this is the dropout. Right? If a non-winner drops out after the election, drops out or is disqualified for whatever reason, the winner should not change. But we saw examples where that was violated as well. That was the NFL football draft. The player we wanted, we wanted one player, a different player dropped out, we re-voted, and it turns out we want someone else now. Yep. Yes. Yes, you will have one sheet of paper, front and back. You can put whatever you want on it.
Whole sheet of paper?
Mm-hmm.
You are amazing.
Very small handwriting.
My only stipulation is that you have to write it. You can't photocopy somebody else's or. Mm-hmm. Yep, as long as you create it, yeah. All right, do any of our methods satisfy all 4 of these criteria? Nope. Do you think there is a method that does? No. Nope and nope. So finding a voting method that satisfies a very small list of simple fairness criteria is of obvious importance to us. We live in a democratic society. This is how we make decisions. So it's really important that we looked for a method that would be fair, that would satisfy these basic fairness criteria. And it was an open question. People couldn't find one. People were working on it up until the late 1940s, and in 1949, there was a mathematical economist who actually proved that you can't do it. There is no method that involves 3 or more candidates. There's no method that will satisfy all the fairness criteria. You always can get some kind of crazy unfair result when there's more than 3 candidates. That's one of the reasons we have such an entrenched 2-party system. So this is sort of a surprising and paradoxical result. It tells us that making decisions in a consistently fair way it is inherently impossible in a democratic society. Isn't that weird? Not the conclusion I expected to see. So you have a little bit of time left. I want you to work in your groups on these 2 problems. So I have given you a new fairness criteria that I want you to play around with. Come up with an example that shows that the plurality method, just counting first place votes, can violate this. So come up with an example where you have a winner who was actually ranked last by a majority of the voters.